Hello all, Chris here. This video is going to be a short introduction to Git, specifically what it is, why we use it, and then a short demo that kind of shows how that works. So Git is a version control system that was developed by Linus Torvalds to manage teams of developers working on the Linux kernel. And in the same way, we use Git in our project workflows at Purdue to do all of our project integration and teaming for multiple programming projects. So developers for all of those might be in different research groups. They might be working obviously in different offices at different times, some online, some offline, and Git solves all those problems really nicely. So just as a quick overview, here is my GitHub page, which has all of my Git repositories. Hopefully you use Git also in your everyday life, or will learn to. So I use Git to manage all of my configuration files for my editor, for my keyboard, for managing my notes, for keeping track of my resume, and really the applications are somewhat limitless as long as you're working with files that can be opened in a text editor and are non-binary, which is to say things that are not images or Microsoft Office documents or something like that. There are specific tools that you can use for teaming on those sorts of things that can make your life easy. So the problem that really Git resolves, or any version control system like SVN or Mercurial or something like that, but we use Git, is this. So if I have some set of documents, in this case it's one paper. So I've written a paper, I make a second version and a third version and a fourth version, and every one has new content or new updates based on revisions from peers or your boss or something like that. You get to a final version, and then you have revisions to that and more final documents. You see what we have here is 7 files that are really all the same file, and this is probably okay if it's just you and these files are small. Of course, if space is not an issue, but if you have multiple people that are trying to team on, in this case I have a LaTeX document, then what can happen is you have a good map in your mind of the development path this paper has taken. So if you start, say, on one that has the revision KLE, which would be one that I would put after I've done a review or something like that, and I start making edits to move the paper in a different direction, and somebody else picks up that same revision and they go with some other set of revisions, maybe they misunderstand the kind of purpose and we review the same content, you get a bunch of clashing conflicts and you have issues where someone's going to have to go through and manually resolve all the changes, which is really tedious. So Git does all of this in an automated fashion for you, and it does that by tracking just the deltas from one version of a paper to another, or really any document or code base or anything like that. And in that way, you have a repository that takes the place of these 7 documents where there's only one paper, and you just check out at various times to see kind of what updates have been done and who's doing them. So by way of a demonstration for that and maybe a little commentary on workflow, I have a little repository here that I've created. Well, let's clear that. So here is a Git repo. Usually you'd have something like this that you'd clone for a project that's on GitHub or something like that, but there's no reason why it can't live on any computer anytime, and everyone who checks out or rather clones a copy of that repository has all the same information, so you get kind of a backup benefit as well. But then you'll have some clones, some checkouts. So here's one that I might have on my computer, one you might have on yours, and we can work on a document. So in this case, if I go into the My Repo and we'll check out master, for example, you can see the full history of development on this project. So there's a case where we've added a file and then we've added some content. If you want to go see what was done for any commit, you take this commit hash and you can do git show and paste it, and you'll see that for this particular commit where we added some content, or the header and content, here it is, the header and content that was added. So if I had more work that I wanted to do, so let's say for example I do git branch, we'll look at my local ones, git checkout Chris updates. So in this case you can see I've done a couple more things here. So I added a section that I'm not sure if I want to keep, I added another paragraph, I added some content, and then that's built on the top of the master that we've just looked at. So now if I look at my file, you see I have the title and header. This is the first line that we saw before. All this stuff is new, and I said maybe we don't want this last stuff, and I can kind of revise all of that content to my liking and collapse it into one commit using some tools that are baked in. Without showing you exactly how that works, I have a branch that has that. Chris consolidated updates. So now if I open my file, you'll see that third paragraph is gone, but all the rest of the content is here. And if you look back at the log of what was done, you'll see there's just one commit that has all of the stuff that we had before and added new content. So if at the same time that I was doing this and doing all of these work kind of items, I guess I should also say if I git check out Chris updates, you can see from the log that one of the things I like to do, and hopefully you'll want to do too in your workflow, is to commit early and often. As long as you're committing stuff, you can't lose information, which is great, and you can push to remote so that it's backed up and other people can see what you're doing. But having said all of that, let's suppose that maybe you also have some work to do. Well, I have to go up your repo. Okay, so here, let's see, git check out your updates. So maybe in the course of your work, you decided that there was a better title to be added, so that commensurately is shown in the git log. Say here, from the very base commit that was in master, here you just added a title. So we did different things at the same time. So usually this is a case where someone would have to go back and integrate all this stuff together, but Git does that kind of naturally by default. So if I check out the dev branch here, then git log, you'll see here's the title added, and then here's my content that I added, and then these are the first two commits here, the added header and added the file. So at any time, you can check the difference between commits. So if I did, I don't know, git diff your updates, you can see that this is my content that I added. If there's no difference, then all of those things will show up as empty, and that's demonstrated here. If I git checkout master, git diff dev, you'll see that those are the same, even though if I consolidated the commits again, which I did in this case, you'll see there are just two here. So this is really nice. You can combine stuff together so that project managers can make nice reports. You can see what's happened. And then in our usual strategy, you can see release commits in master and kind of the working stuff in dev. So just to kind of give the overview of how we usually would use Git in a workflow, if I clear this and do git branch here, this shows all the local branches that you have, and future videos will explain what everything else is here. But the general strategy is that there is a master branch, and this master has always got good working code. It's got compilable documents. It's got basically the latest stable revision. Dev is the place where we all work together and share our work, and then that gets combined logically into releases for master. And then when you want to go make updates, you take the dev branch and you make a little copy of it to make custom updates for yourself, and then we roll all of those together nicely so that the commit log looks like a one step after another of serial work, even though in actual fact we may have worked kind of together all at once. So that's a really quick overview, but the benefit here again is that Git takes all of the multiple versions problems and reduces their impact or eliminates that for you, so you have just one set of documents at any time anyone can look at. If there are conflicts or diffs that need to be resolved, Git will do that automatically for any place that you don't have conflicts, and then you have your final version there at the end. So I guess as one other kind of caveat point, Git works in a line-by-line fashion. So if you're somebody that writes LaTeX and you write long paragraphs, for example, then Git doesn't do you as good a service as if you're working on code or if you put all of your sentences on different lines, that kind of stuff. So that's been the first video introduction to Git. In the future, I will release some other videos on the finer points of Git, how I did all of that stuff, how to manage branches, and what all the different kind of pieces and parts are and what they mean. If you'd like to get ahead of these demonstrations, then you can go to Atlassian.com. There are a lot of good tutorials there. You can do your learning on your own in maybe a more visual way. But until the next video, this has been a summary of Git. Thank you for watching.